I think I am live now. People in the chat, do let me know if audio, video, etc. everything looks good. Then we will start discussing problems for today. I was able to solve the first four problems, so I would definitely discuss first four problems. Like I will see if there are some good enough solutions for you. If yes, then I will discuss you. Otherwise, that's just four problems only. And do check out the Chrome extension that I have created. Like this contains like this can put in like all the video tutorials that I have created for all the contests in a sidebar over here. I have also updated to add a behavior search on YouTube, so you can also find other people's tutorials on YouTube over here. So this is where we are. Like people in the chat, do let me know how many problems were you guys able to solve. So this will give me some fair set of idea of like how many problems, which problems I have to target the most. And yeah, like let's get started now. Looks like large majority of the people is on one or two problems. Like okay, we have people with four ACs as well, and we have people with 5 to 6 ACs as well. Like that's actually great. Like for the rating, you can possibly look at clist.by. It would be available in some time. So it's getting updated over here. Like once CFS is done with refreshing over the ratings, you can check the problem ratings here. Okay, let's get started. First problem says Papyrus came up with another puzzle for Frisk to solve. Papyrus brought two arrays A and B of length n, allowed the following two operations to be performed. Choose any index I and change AI to AI minus 1. The execution time of each operation is 1 second. Reorder all the elements of array in any way. The execution time of such an operation is 3 seconds. You need to convert A into B. Frisk wants to solve the puzzle as soon as possible. Help Frisk determine the minimum time needed to solve the puzzle. If there is no solution, output minus 1. So, like overall, it says you are given an array. We can change some of the elements. Okay, but yeah, can you increase the volume? Okay, let me see if it helps. Like, I'll try to pull in mic a bit closer. I hope that gives a better audio. So essentially, the problem is like this. We have an initial array. We can initially decrease some elements by minus one, and then we can rearrange all the elements of the array as well. Now we have to figure out if we can convert one particular array into another array or not. And the cost of the each operation is also given to us. So like the way I would probably solve this problem is like this. First, I will say that I have to reorder elements only once, because let's say I subtract some elements by minus 1, then reorder the element, then subtract some more elements by minus 1, and then reorder the elements. Then like the first time when I reorder the element doesn't really make any sense, right? I can first subtract the one, skip the reordering on the second time, then subtract the remaining elements, and then reorder again. So with this, we have claimed that we can reorder all the elements only once. Next, I am trying to say is like whether we first subtract elements, then reorder, and then subtract. Instead of doing it this way, we since we know that we which elements we are going to subtract for, we can do it before as well. Like what I am trying to say is as follows. One second. So what I am claiming is, one second, let me see why my tablet is not working. One second. Okay, like why? One second, give me a minute. Not sure what's impacting my pen here. Just give me 2 minutes. One second. Okay, this works. Okay, I think we are good now. So yeah, like let's look at it this way. First, let's say we have this array. One second, wait, it's moving a bit too fast. Mm, Okay, I think let's see if we can get it working somehow. So like the idea is as follows. Let's say we have an element this A1 and Y. Wait one second. Man, sorry. Okay. I think okay. I think I will leave whiteboard for today and try to put some. Fix this up later. Let's remove whiteboard altogether, man. One second. Okay, let's get started. So sorry for. So like the idea is as follows. Let's say you have A1, A2, A3, A4, A5, and so on. Now we can first decide which elements to subtract and how much to subtract from each element. For example, -2, -3, -4, -10, and -20. Then let's say if we reorder the elements and then we subtract more and then we reorder elements again. Then what I am claiming is like there is no point in doing the first reordering because you can always put each index where you want to put at the last only. And if you are subtracting something after reordering, you can just subtract that index before as well. So overall the idea is and then we will reorder. This is where we are. And how many times? Let's say like the answer is never -1 so far. Let's forget about -1 case. Then can you find out how many times you have to subtract some elements? Like count of subtraction is simply sum of A, like the initial number of times, and sum of B, like the number of times you have to subtract. So the number of -1 operations are already fixed. What matters more is like, and reordering would be required. And then we have to also see if some reordering etc is required. So what I am doing is first let's check the number of operations required. If we can get B from A without reordering. This means like since you are not reordering it and you are only decreasing A, for each AI, you should have AI greater than BI. If this is true, then no reordering is required. Like that is an easy case first for us. If A and B are equal, skip it. If there is any index I which is less than BI, then we cannot get reordering, so skip it. Otherwise, you just count the number of elements. Or I think I will just leave it infinite. Now, what I am claiming is, let's say if we have some array 1, 2, 3, 10, 20 as B. Then the number of A's that are like, for example, number of A's that are more than, like overall the idea was if we have a 20 here, then there should be at least one which is more than 20. There should be at least two A which are more than 10. Because you see, like for these two elements, you have to start from somewhere more than 10 and get to that element. For this 3, you have to get some element more than 3. Like there should be at least 3 elements that are more than 3. So overall, that was the idea for the second count. Like basically, you pair the largest element with the largest element, second largest element with the second largest element, and so on. Now you go, you have operation for one time reordering, and if there is still an AI which is less than bi, then the answer is infinite. Like you cannot reorder elements, otherwise you need to just count the sum of the elements. Now I have an answer, once with reordering, once without reordering. If both of them are infinite, basically an impossible case, then I print -1, otherwise I print what are the values. And that was the overall idea for the problem A. Any questions, anyone? The main idea was, if the largest element is 20 in B, then there should be at least one A which is greater than equal to 20. If the second largest element is 10, then there should be at least two elements which are greater than equal to 10, and so on. If the third largest element is 3, then there should be at least three elements which are more than equal to 3, and so on. Any questions, anyone, on problem A? Otherwise, we will move on to problem B then. Like actually, like the same algorithm will also work without reversing it as well, but reversing just makes it a bit more natural to see, because the claim is like looking at the, if there is one largest value of B, and like at least in terms of implementation this will also work. Yeah, like I would agree, like in general I found all of these problems to be little harder than the usual ones. Like my overall idea was as follows. Like I don't know about E yet, to be honest. Like once I am gone, I reach E, I will probably look at some Codeforce announcements and something. If like this is overall idea for this problem. Like at least in terms of implementation, you can definitely AC. Like just sorting is enough. But revert just makes it slightly easier for you to see like why this concept, how to figure out -1. Yeah, like I'm going through A, B, C, D. That would be my order. Crimson template. After summoning the next boss, the brain of Chotlu note. I don't know what the name is. You notice that it surrounds itself by n eyes, numbered from 1 to n. In one attack, the brain of C chose a triplet of eyes, TLDR. We have to choose three integers A, B, and C, such that all the elements are between 1 to n. And this particular identity, the LCM of A and B and LCM of B and C, and then GCD of them is equal to GCD of A and C. So, like n square will possibly not work for B. Like overall, it says we have to choose three integers, such that this identity of GCD of GCD of A comma C. This is what we have to figure out. Looks fine, right? Now let's first assume that there is some common GCD G of A, B, and C. Like I am trying to simplify things one after the other. Then we can write A as G into A, B into G into B, C equal to G into C. Like this is first level of simplification in the same identity. Then this becomes G into A, this becomes G into B, this becomes G into B, this becomes G into C. This becomes G into A, this becomes G into C. Right? Now the crux is like if there is a common element that multiplies both of the elements in the GCD, then I can actually move this element out. Because if there are two numbers that are multiples of 2, then their LCM would also be a multiple of 2. Looks fine, right? This is how I can write this equation to be. And now we have this again G that multiplies both the elements and we want to take a GCD out. Here also we have same number that's multiply both of them. So we can actually even move this G out from here. And now the idea is like we can remove this G altogether from both the sides. Now we are left with this part. Looks fine, right? Like any questions so far in the simplification of these equations? What I have tried is I have assumed that G to be GCD of A, B, and C. And then I have tried to simplify it by making all the elements A, B, C, A co-prime. Like because if G is a multiple of this, there should be some part of A after removing G, some part of B after removing G, some part of C after removing G. And like the equation again becomes the same after removing that common part. Then how does LCM of A comma B looks like? A into B divided by GCD of A comma B, right? Like this is the identity of LCM and GCD comparison. Similarly, LCM of B and C would be B into C divided by GCD of B comma C. Like this is one of the identity for LCM and GCD of the numbers. And if I try to put it in the above equation, into something. Here also it will become C into something. Like this something is essentially here its first part is GCD of A into B divided by GCD of A comma B. Here it's C into B divided by GCD of B comma C, which is your GCD of A comma C. This is where we are. At this point, it becomes a bit too tempting to probably assume that this part does not contribute in the answer and this part also does not contribute in the answer or something like that. Or like how do I put it? Like one possible idea like here becomes crazy idea which I had was let's say if somehow GCD of A comma B is B and GCD of B comma C is again B, then this something will become just one. And this will also become once and this equation trivially holds true. or like I will not put it this way. And at that point of time, the idea I came up with was, let's say A is a multiple of B and C is a multiple of B. Will always be. This is one way to look at it. And another way to look at it here is probably, let me see if we can get something. Now, can I again put G2 in, like, let's say we have G2 equal to GCD of A comma C. Then let's call it A equal to G2 into A2, C equal to G2 into C2. That's fine. Like now we are trying to simplify this part as well. Then we will end up with GCD of G2 into A2 into B divided by GCD of A comma B. G2 into C2 into B divided by GCD of B comma C, which is equal to your G2. And again, you can move G2 out from this side and divide it from both sides. You will end up with this. This is one. Now, when we are at this equation, what you can see is like some factor of B can come out from here and some factor of B can come out from here as well. But because the overall GCD should be 0, then GCD of B divided by, because like this number is formed from two numbers, this is also from two numbers, and they should never be equal. Here we are fine, like A2 and C2 will not have any common multiples. These two numbers should definitely have GCD equal, GCD as one. And you can notice that both of these two are some factors of B. Like, are you with me so far, or there are any questions over here? Like the derivation is a bit non-trivial, definitely. It's much easier to choose by making some assumptions over here, but yeah. So like these two numbers are divisible, some divisors of B, but their GCD should be 1. Then only the GCD of whole equation can be 1. This can happen only if the prime set of these two numbers and the prime set of these two numbers is what? Like they should not have any common multiples in them. Or let's see, like if I can probably simplify this a bit further. Mhm. How do I put it? If let's say B is 100, mhm, let me see if someone has a better derivation over here. Like it's easier to put an hypothesis over here. See. Okay, there are no submissions. That's fine. uh Like my primary claim was like if B divides A and B divides C, then this equation will always hold true. This part we can definitely prove it. In this case, LCM of A comma B will be A. LCM of B comma C will be C. So your original equation will become GCD of LCM of A comma B would again be B. LCM of B comma C would again be C, and which will definitely be equal to A comma C. This part is fine. What happens if B does not divide A? Then LCM will put in some, bring in some more elements. Let me try to form some counter test case or something. Or like 1 second. Let's say B is equal to 10. A is equal to 2 into 7. C is equal to 5 into, that's fine, right? GCD of A and B, LCM of A and B would be like this is 2 into 5. LCM of A and B would be 2 into 5 into 7. And LCM of B and C would again be 2 into 5 into 7, which is definitely not equal to GCD of 10, comma 20. Okay, let's probably keep it a bit simpler. Let's focus on each of the prime factors. Let's say for a prime P, in prime factorization of A, it's P to the power I, and then the remaining part. It would be something J and it would be something K. That's fine, right? And we will try to solve it for all the prime factors. Then LCM of A comma B will have prime factor as max of I comma j. LCM of B comma C would be maximum of j comma k, and GCD of A comma C will be minimum of I comma j. And now if we put in all the equations, we will end up with maximum of I comma j I think we are back. Yeah, this makes more sense. And on this side, like due to GCD, the maximum power of P would be j comma k. And here we need minimum of I comma k. Now you can see that you can write this part, rephrase this part again as maximum of j comma minimum of I comma k. When will this equation hold true? So from this part, you can conclude that j should be less than equal to I. J should be less than equal to k. And actually, this is a bit more simpler proof. Like, I'm not sure if you were with me so far or not. Let's probably start once more. What I am saying is, let's look at the all the prime numbers, and let's say if for a particular prime p, the power that divides a is I, power that divides b is j, power that divides j is k. Then we know that LCM of a and b will have the power which would be maximum from these two. LCM from b and c would have the power that is maximum of these two numbers. And GCD would have the power of p which is minimum of these two numbers. Like LCM will have maximum prime power and GCD will have minimum prime power. So now you can rewrite these equations as first you need maximum power from A and B, maximum power from B and C, and then take minimum of all. That should be equal to minimum of I and K. Now you are taking two number with max J and two numbers with max J. What you can do is you can keep this max J out. First you can take minimum of I and K and then take a max with J, rather than first taking with max J and then dividing it by I. So you can rewrite this part as maximum, first take minimum of I and K and then take maximum of all the values with J, and that should be equal to minimum of I and K. And what I am claiming is, like, now you can see this equation can hold true only if whatever the minimum of I and K is, if J is less than equal to minimum of I and K, then only this equation can hold true. Now this gives us, okay, like the prime power of J which divides A and C and J is less than equal to K. If P to the power 3 divides B, then it must divide A and C as well, because the corresponding prime power in A and C would be more. And if you look at it for all the prime numbers, then this will translate to B should divide A and B should divide C. Any questions here? Like, this is now the bold statement. And once you have this, you would be able to solve the remaining part. Like, how did we prove that B should divide A and B should also divide C? Then only like the original equation we have can hold true. Definitely not as simple as derivation it is, but yeah. Like, this is how I would try to prove it if I have to prove it. And once we have this, then we can solve it this way. We iterate on B. We iterate on B from 1 to n. Then how many multiples of B exist from 1 to n? Like the number of factors of b between 1 to n would be n divided by b. Like these are the times you can multiply it by. Then for A, you have fact count choice. For B, you have fact count choice. You sum it all and you will get the final result. Any questions, anyone on problem B now? Any questions on problem B? Then we will move on to problem C. Okay, why do I square? Like first, did you understood why? How did we got floor of n by b? Like one is for A, one is for B. A should be equal to some n into B. C should be equal to some m into B. Number of ways to choose. Like let's put it this as K. K is anything between 1 up to n by b. Number of ways to choose m is also 1 up to n by b. So now the number of total k and n is n by b choices here, n by b choices here. So that's why we are squaring. Yeah, I am squaring for A and C. Hmm. At least, does anyone have any simpler proof for this? Like, can you explain the last line of the equation? Can you please share which particular line you are talking about? Is this about this? How did we got from here to here? Like honestly, I'm not sure about E. Like I will when I reach E, I will look at what other people have submitted. If I understand them, then I will discuss E. Otherwise, I will skip E. Like right now, I don't know how to solve it. So that's where yeah. Yeah. So the idea is this value would be at least I, right? Sorry. You have two numbers. You first, if they are less than J, you increase them up to J, and then you take minimum of those two numbers. That's how I would interpret this part, right? I have two numbers I and K. I will first increase them to be at least equal to J, and then I will take minimum of that part, minimum of those two numbers. What I am saying is even I can do it reverse. First, I take minimum of those two numbers, and if that minimum is less than the J, then I increase that number up to J. This is this part. This is increase I up to J if its I is less than J. Increase K up to J if it is less than J, and then take minimum of both two numbers. What I am saying is rather than doing increasing both the numbers, you first take minimum of these two numbers, and if that minimum itself is less than J, then increase it up to J. And now you can probably try to make all four cases as well when I is less than J, when I is more than J, when when K is less than J, when K is more than J, all four combinations, and you will see like this part becomes equal to this. So that's how we came up with this. Now I am saying I have this is one particular number. This is one particular number. Right side says if that part is less than J, then increase it up to J. While the right part says if keep that number as it is. Then both of them can be equal only if that part was more than K in the first place. Because if this was less than K, then maximum here would be J and this would be less than J. But if it's greater than equal to j, then here this would be equal to the same number and this is also the same number. So the way to interpret this number is like, let's treat this. Then it says maximum of j comma v is equal to v. The way to interpret this number is, you have a number v. If that is less than j, then increase it up to j. But on right hand side, you want to keep the number same as well. Then this can happen only if j is less than equal to v. So that's how we have problem B. Any questions, anyone on problem B? If not, we will move to problem C. Okay, editorial is posted, then I will look at editorial and then go to problem C. Okay, let's move on to problem C then. It says, during his long adventure, Steve stumbled upon a village of villagers. The houses in the village are connected by bidirectional path. In total, there are n houses in the village, numbered from 1 to n. The graph of the houses and paths represent a rooted tree, rooted at vertex 1, where the town hall is located. Consider an arbitrary house and its subtree. For each such house V and each non-negative integer h, consider the set of houses that are the subtree of V at some distance exactly equal to h. Like a long story short, what you have to choose two variables. You have to choose a node and you have to choose an index h, an integer height h. Then in that node subtree, you have to look at all the nodes that are at distance h from that node, and you will select those nodes out. The problem says, can you find like how many different set of elements you can choose? For example, in this case, if you choose 4 and distance as 2, then you will end up selecting 6, 7, and 8. But you can get the same elements even when you choose 2 and the distance as 3. Choosing 2 and distance as 3 will also choose 6, 7, and 8. Choosing 4 and distance as 2 will also choose 6, 7, and 8. But both of them should be deduplicated. Like, you should not count these two as different ways to choose the same element, because at the end of the numbers, if you choose the elements 6, 7, 8, then they are same. And then it says how many different set of elements you can find. Any questions, anyone so far? Any questions, anyone on the problem statement? So this is where we are. Like, unfortunately, I don't have a whiteboard, so the way I'm choosing is this. Let's look at a particular node view. And height h. If there is only one child that has nodes with height greater than equal to h, then the set of u comma h will be same as set of child of u comma h minus 1. Do you agree on this one or not? What I am saying is, if I am choosing a node u and some height h, but if there is only one child at that height, then I can very well go one node below it and choose height h minus 1 as well. Like the nodes I would be getting would be same only. No, like height is when h is greater than equal to 0. No, so far I'm not finding the height of the nodes. I'm trying to simplify a few lemmas and then I will try to use them for myself for some another use case. But if there are two child that has nodes rather than height, I think distance is the better keyword. Let's say distance d. If I choose a node u and a distance d, then if there is only one node that has distance nodes with distance d, then instead of u comma d, I can choose that child and d. If there are two nodes with distance d, then I cannot get this set by using any other child of u and whatever d I have. Like if there are at least two nodes, children that have nodes at a distance d, then if I have to choose any other sub node from the subtree of u, I cannot get the same set of nodes. Either I would be outside, I would choose some node that is not, like let me put it this way, and so on. Let's say C2 has distance greater than equal to d. C4 has distance greater than equal to d. Then if I choose any node in C1, then I cannot get the set that I choose with u comma d. Because like the childrens of like the nodes that are in subtree of C2 and C4 will not be there in subtree of C2. If I choose any node in CT of 3, if I choose something from C2, like the set of nodes I can get would be at max the childrens that I would get from C2, but I cannot get both of these together. And I can say the same for the remaining part as well. Do you agree on this one? So like this is where we are like I believe like the unique way to choose the nodes here is this only. So what I need is find maximum distance in each child. Let's say from you, like in each child, the distance is 2, 4, 10, 7, and so on, something like that. Then I will get unique candidate of set as long as d is less than equal to 7. And like this actually solves this problem. And number of is 8, which is you can choose 0 up to 7. And this is where we are. Any questions, anyone on this lemma? Then we will try to solve for this problem. Now, the way to solve for this problem is DFS. Like this, DFS tree will become maximum height over there. So, like the node which has maximum distance from V plus 1 would be the maximum distance from this node. Now we can sort all child heights here. If we have at least 2 children, then answer would be second max plus 1. Otherwise, the answer would be plus plus. You can just choose the current one. And then you return the one that has the maximum one. And like this is actually the solution. Like the code is a bit small over here. Any questions, anyone on this problem? Then return this. If there are no children, then just return 0. Okay, how do I find heights using DFS? Yeah. Like overall, the idea is as follows. Let's say we have this tree. Let's say this is our tree. Like what would be the node that has maximum distance from it? You can find maximum distance from 9, do a plus 1. You can find maximum distance from 10, do a plus 1, take maximum of these two. So like the node from that has maximum distance from 9 is 0 distance only. Maximum distance from 10 is 0 only. So maximum distance from 8 is maximum of all of these plus 1. That would be the maximum distance from 8. Similarly, if I have to find maximum distance from 2, I find maximum distance from 3, I find maximum distance from 5, I find maximum distance from 6. Take maximum of these and plus 1. And that's all you need to do. No, like it's not faster than recursive, it's order run only. You visit all the nodes once and figure out the maximum one. Like DFS is also a kind of recursive. So when I'm doing DFS, I'm visiting it in a particular order. I don't need to save values at any point of time. You can also very well do something recursive and do it. That will also work actually. No, like with recursive, you need to be a bit careful to use DP there. Otherwise, you will definitely get a TLE. This way, you can find maximum from all the nodes and then take maximum, second maximum, whatever you want. And you will realize that this is same as doing. I was doing the same thing with just one DFS above there. If you don't use recursive with memorization, then you will definitely get a TLE. Like you can have a long node, see like one has child two, two has child three, three has child four, four has child five, and so on, and you will get it. That it will be TLE. Yeah, like go back and try for your TLE solution again. Just ensure that you put in some memorization like this here, and that should, I believe, would get an AC. Because like you can see like a long node which has child 1 2 2 3 3 4 5 6 and so on, that will get a TLE. And if you try to put in early checks, then you can probably try to put a complete balance binary tree. Then just doing recursive there would also get a TLE. The 1 has children 2 and 3, 2 has children 4 and 5 and so on. Any questions anyone on problem C? If not, then we will move on to problem D. Just let me know if anyone has any questions on problem C. If not, we will move on to problem D. Actually, again, D, I tried to guess something and that actually worked. So I did not bother proving it in the contest. But now let's see if we can prove something. Actually, one more thing is like it doesn't really prove says what this chain etc is. You and Johnny Smith Silver and decided to form some Arasakas together. After making your way through the guards, you reach XYZ. The TLR is we are given a number n. We have to consider all the divisors of this number except one. And we have to put it in some partitions such that if x is in the partition Li, then all the divisors of x, x of 1 and x should be in the earlier layers. And in each layer, the numbers should be ordered in such a way that there are nearby numbers which have GCD greater than 1. The length of the password is defined as the number of layers, and we have to make a lot of mess over here. Like the problem primarily says is as follows. Some arrays. Let's put it this way. We have to put all the divisors of the n in some arrays. A1, A2, A3, and up to some A. No, like Rusi- Rusike's, I believe is right. I looked at how the answer for 127 and assume something in 1. Now it says if x is in, then all the other divisors of x should be in A1 up to AI minus 1. So kind of like this, whenever you are adding more elements to some number, like in some part, then all the devices are already in that part. And we should be able to elements in AI such that GCD of is greater than 1. Like this is what the problem statement primarily says to us. Any questions anyone on the problem statement so far? Like any questions anyone on the problem statement? Like the problem statement was a bit tricky. If there are no questions, then I will jump onto the solution. Yeah, I can definitely put all the numbers in one layer if I can somehow satisfy all the conditions, but most of the time that won't be the case. So 120 was a good number to play around with. And let's say we chose some number n, which is 2 to the power 5 into 3 to the power 6 into 7, 11 to the power 3. Right? Let's put it this way. And at bare minimum, what all layers you will need. For every increase, like if you have 2 to the power 5 somewhere, like let me put it this way. If this is the number, this is in the last layer. Then the second last layer should have at least one number after removing this prime. If I remove one of the prime, then these two numbers cannot be in same layer. Because your condition is for this number, all the factors should be in the layer above it. And now if I focus on this number, then if I remove some prime factor out of it, then this number should be in the layer above it. Because we cannot have these two numbers in the same layer. Does this looks fine? And I can go on a bit more. Now if I remove one of the prime, then these two numbers cannot be in the same layer as well. because this is the divisor of this number, and the condition is like for this number all the divisors should be above it. Like these are the layers you will end up finding at a bare minimum. Like all of these layers are forged. Okay, for example, for this number, there should be one layer before it which has 2 to the power 3 because these two numbers cannot be together. So once you know the prime factorization, you know that the minimum number of layers you will get is 5 plus 6 plus 3. Like every time you would add one more prime number in each of the layers to get the final number to build up. So, or if I have to put it this way, if n equal to p to the power I into q to the power j into r to the power k, then on each layer, if I plus j plus k is equal to 6, then we should have all the elements with I plus j plus k less than equal to 5 in layer before this. Any questions, anyone? Like all of these are forged. Okay, like you would need at bare separate layers where you have all of these numbers. And the idea here is along with this 3 to the power 2, you can also put in 2 to the power 1 into 3 to the power 1. Again, the sum of I and j is same. And you can again put here 3 to the power 2. You can actually make all of these in a chain like this, and all the adjacent numbers are GCD more than 1. Here also you can try to put other numbers as well. And after this, you can also make 3 to the power 1 into 11 to the power 1. And then you can make 11 to the power 2. That's how you can try to move all the numbers around. For this as well, once you have 2 to the power 3, you can also make 2 to the power 2 into 3 to the power 1. Then you can remove one more factor, 2 to the power 1 into 3 to the power 2. Then you start adding 11 as well. No, like adjust you. This is not a cyclic array; it's a simple chain, so you don't have to bother about the first and last element. Now you can go a bit further as well. Then you can remove 2 completely and make it 3 to the power 3. Then you start decreasing 3 as well, and you start adding 11 again. Now, the way I would put at it is, let's first put all the numbers that have only 2 in them, then put all the factors of which have 2 at least. 2 to the power 2 into 3, 2 to the power 2 into 11. Then you can go with 2 to the power 1 into 3 to the power 2, 2 to the power 1 into 3 into 11, 2 to the power 1 into 11 to the power 2. Like you can put all the other prime factors, just keep one of the factors. So Once you are done with everything, now then you can start with 11. Since you have 11 to the power 3 here as the last number, you can start with 11 and 3, 11 to the power 3, 11 to the power 2 into 3, 11 to the power 1 into 3 to the power 2. And once you are done with all the numbers that involve 11 but not 2, then you can start putting in 3 as well. 3 to the power 3 and so on. So the crux of the idea is the layer where you have 2 to the power 3, you can actually put in all the prime numbers such that the sum of the power of all the primes is 3. And you can arrange it in some form. The idea would be like first you have 2 to the power 3, exhaust all the multiples of 2 that have sum as 3. And because the first number you took was all the multiples of 3, then the last number you would get in the chain would have some another prime apart from 2. Then for that prime, the immediate number you put is that number to the maximum power, and then you start adding all the other numbers as well of the prime as well. And once you reach the end of this chain, the other number you have, you put it like, you see, like you would be able to always figure out some numbers of this form. Okay, like once you are exhaust all the multiples of 11, then you pick another prime that also says one of the prime with the last number. You put that maximum power first and then everything there. Because we have added the maximum power as the first number, whatever the next elements we would be adding would have more factors over here. And the only case there this would fail is when the power is 1. You cannot have 2 to the power 1 and 3 to the power 1 together because they don't share any number over here. So we will have to put it in the separate layer. Similarly, 11 to the power 1. Only when we are looking at prime 1, we have to keep the layers separate. Otherwise, we can keep the layers same. So the number of ways to solve for this problem is the number of layers would be 5 plus 6 plus 3, which is 9 plus 4, 14 layers at max you need. But when sum is 1, we need 3 layers. Because you cannot have all the, like, basically each prime should be in separate layer. So this is where we are. And the way we would factorize these numbers would be using sieve to keep one bare minimum, and then we factorize using lowest prime factor. So first we run a sieve to figure out for each element what is one of the prime, at least one prime numbers. Then we have n. Prime count, we keep prime count 0. Power sum as 0 again. Whenever we find a new prime count, we add it. While n divides p. And overall number that you would need would be, this would be the number of layers you need for 2 up to the prime sum. Plus prime count, this would be the number of layers you would need for sum equal to 1. And this is your solution for problem D. Any questions, anyone on problem D? If not, then we will move on to problem E. Like for problem rating, you can actually look at CSCS. This actually rates all of these quite low, possibly because of lot of ACs here. But I would actually rate this problem to be around 1700 or 1800, something like that. At least 1800 is something that I would rate for. This would be 1500, and this is also the 1500 if you are trying to prove it. If you are not trying to prove it, then this would be gas by AC. And this is the most easiest problem of the set. And I could not solve for it. I'm not sure if I would call it 2000 or something, but yeah, that's very. Any questions, anyone on problem D? If not, I will read the editorial of problem E. If that makes sense to me, I will try to explain it. Otherwise, we will wrap up this thing. I can't understand this website. Which website are you talking about? Is it series.b1? Like actually, these ratings are quite accurate in the world without LLM. Like the way these ratings are calculated, it looks at what is the rating of the people who have solved this problem, and what is the rating of people who did not solve this problem, and then it tries to figure out like what would be like if like we have something elo rating using which everyone's code forces rating is calculated. So based on who like if you solve this problem, this website consider that you won against that problem. And if you could not solve that problem, then this website considers that you lost against that problem. And based on with against who all won for this problem and who all failed against this problem, it tries to figure out the median rating of this problem. And that's how these ratings are calculated. In the world of LLM, like problems usually have a lot of ACs and it doesn't accurately reflect the problem. Yeah. Similarly, we have Canco for ad coder. Like this also figures out rating in the similar fashion. Like problem rating is there based on the similar idea, like who all won, who all failed. I haven't like if you put in your handle here, then you can also figure out how much rating approximate time you would need to solve this problem and what is the probability that you would be able to solve this problem. Again, the fundamentals are same. Because you know the rating of a problem, you can use elo to figure out like what is the probability you will win against that person. There is a formula for it, and I'm not sure how these guys compute time and all, but this is where we are. So this is where we are done with ABCD, the problems that I was able to solve in the contest. So 600 or something like that. Cool. Let's look at the editorial of problem E. Like actually, I would strongly suggest that you should do AdCoder ABC, AdCoder beginner contest. And this is one of the first advice I have on my roadmap to Rad channel. Participate in AdCode ABC is a no-brainer. One second. Wait 1 second. I had n to the power 4 solution over here, but I cannot figure out what's happening over here. So I, F, and S make sense. Minimum possible value of global maximum sum on this prefix. Okay, interesting one. Okay, this is actually an interesting idea. Like it optimized n to the power 4 solution into n cube by moving one of the states into the DP. Any questions, anyone so far? Else we will try to move to problem E. And this E would be the last problem for us today. Any questions, anyone up to A to D? Then we will go for problem E. Like you can just do some virtual contest of the previous ad coder beginner contest, and that should be good. And so let's read the problem statement E once. A lot of stories, but it says we have a string S. If SI is T, then we called ith cake is real. If SI is F, ith cake is fake. If SI is N, then we have not yet decided whether a cake is real or fake. First, we try to put some values for N so that we make each cake either a fake or a real one. And then we have another person, Sal, who will choose some range of the cakes and say that this particular range is fake cake and the remaining cakes are true. So we have cakes like this. S is a string of T, N, and F. We replace each N with T or F. Then cell will then first like then Alice will choose some subarray and say that the elements look like this. Like initially you have T, then the chosen parts are F, and then the chosen parts, remaining parts are again T. And number of mistakes is equal to places where R string S is different from what LS cell S. This is where we are. Looks great, right? And cell wants to minimize mistakes and we want to maximize it. Any questions so far on the problem statement? So this is where we are. And the way we can solve for this problem is as follows. Like, let's say we replace like the original number of, then the mistakes would be like first minus f in selected parts. This would be the total number of f that you could not predict for. Like total number of f in the original array minus the number of f in the subarray we have selected. Like those would be the number of fake cakes outside our selected range that we could not predict, plus number of p in selected part. Like these are the cakes that were real, but because we chose a subarray, we ended up choosing values incorrectly. Like, does this way looks correct to count the number of mistakes we have made? Number of mistakes we have made is number of fake cake outside the range we have selected, and the number of real cakes we predicted as false inside our range. Yeah, order n cube is around 1.25 into 10 to the power 8 or something that will actually get an AC. So now the idea over here is as follows. We can keep DP states as follows. We can split it into two parts. Change F to 1, F to minus 1, and T to 1. Then what I am saying is, like this part is same as right, because whenever in my selected range, if there is a T, then number of mistakes increase by 1. If there is F, then number of mistakes decrease by F. And no, let me put it this way. Change F to 1 and T to minus 1. Then my answer is total number of F minus the sum of selected range. So if number of F is fixed, then minimum number of mistakes is total number of F, which is constant, minus maximum subarray sum, right? Because I want to minimize the number of mistakes, so I should choose the subarray that has the maximum sum. So if number of mistakes is fixed and already given to you, then the way you will choose, like because when I am getting in the array, all the elements are already T and F. So the number of mistakes is total number of F in the array minus the maximum subarray sum. And how do you find the maximum subarray sum? We can use Cadence algorithm. Like Cadence algorithm has 3 states. Cadence algorithm has maximum sum seen so far, maximum suffix sum seen so far. Right? So if we can somehow create a DP state that has 3 elements of F, maximum sum seen so far, and then if I maintain all of these and like then I would be able to in principle figure out all the topics here. And I need to also keep an index I, and I have to keep incrementing one more element over there. So these four DP states, overall it would be n to the power 4 or something. Let's implement this first and then we will make it n cube. DP like the states are number of f, maximum suffix sum, maximum sum in the cadence. Maximum sum, why do we need to maintain it? So actually the reason is you can figure out maximum value only when you have processed all the n elements so far. You cannot get it, you cannot do it before it. So that's why we are maintaining total number of f and the maximum sum seen so far. Because if you just maintain current sum and maximum sum, one second. Like this is my current sum, this is my maximum sum, right? Like current sum is what I'm calling it a maximum suffix sum, nothing more. Yeah. Like because whenever the current sum becomes less than 0, you make it 0. So that is always equal to maximum suffix sum. Maximum suffix sum for each index. So I believe you and me are on the same page. Probably some different terminologies here. I create a new DP state. Let's use current sum variable. This is its site. Let's first solve when x is equal to 2 or x is equal to n. When we are trying to put new f count would be same as f count because we have not added, we are adding true here. For t we are adding making it 1, right? For t we are making it -1. Maximum comma new correction. Like let's just make it a boolean vector only, like what all states are possible. We don't need an integer yet. Like we are maintaining which all states are possible. If the current sum, this is actually a 3D DP. If this state is not possible, then we skip it. And otherwise, new F count, new maximum, we mark it as true. Similarly, if we put false at the current place, which can be when x is true and when x is false, we are changing x equal to +1, so this comes here, and the all algorithm complete remains same. And then we replace dp with ndp, whatever we have. Like let's just make it n+2, so we don't have. At last we go over all the values. Like we can probably keep all of this together as well. If this state was possible, then the value in that case is f count minus maximum, whatever we have found. And we take answer over all the possible states. Any questions, anyone so far? Like this is n to the power 4 because we have n cube states. Wait 1 second. Mhm. Okay, this should be false to begin. Okay, 1 second. Let me see why it's not working. Our algorithm is total number of f minus sum of the selected range. Sum of the selected range is f turns 1, t turns -1. Okay, here we have to even increase the count of the f, right? Yeah. There are n cube states, and then we go through all the n cube states one time. So overall solution is n to the power 4. But any questions, anyone on this n to the power 4 solution first before we jump on to n cube solution? This will get a TLE, but what I'm trying to prove is like the solution is correct. Any questions, anyone on this n to the power 4 solutions? Then we will go into n cube solution. So I actually have a similar video as well where I'm doing a lot of DP optimizations. And I would actually suggest everyone to even go through this problem as well. Like here, I have discussed many ideas on how you can optimize DP states. My overall idea is like in this case, like, what editorial is doing is we don't really need right now. Our DP state is as follows: number of f maximum sum and current sum, and does this state exist or not? And at last, and number of. So the idea is we can change this DP state a bit because number of f current sum. What is the maximum sum possible? And this will actually change it into an n cube solution. Like instead of keeping three states and whether that exists as true and false, you remove one DP state out and put it as a value and you try to maximize there. And this is what the editorial changes. So now we can go back. We can change it to a 2D. For the 0, 0, the maximum sum seen would be 0. For everyone else, we call it minus infinity because that's not possible. Maximum source goes away. You have some new current sum is PVR maximum sum, and if the new sum also breaches that. This is where we are. And the same goes for the other half as well. And then we remove. Okay, I'm making mistake somewhere. Okay. Mm-hmm. 1 second, let me see. Like the idea is this. Like, am I initializing the states incorrectly? Okay, I should not initialize negative states as well. Mhm. Can anyone spot a mistake somewhere? This is my running sum. Mhm. For 0, 0, it would be 0. No sum so far, maximum sum is 0, and we have this element. We go over all the F count. We go over all the current sum. We take the previous sum from the DP. If it's negative, then this state is unvisited. New F count for a positive remains same. The current sum decreases by 1, and we again take max with 0. Maximum sum would be maximum of whatever the previous sum was and whatever the new sum is. For this state, we take this and new maximum. If it's negative as well, this was our previous sum. I think n plus 2 is fine. Like, the number of f cannot be more than n, the number of current sum cannot be more than n. Move out impossible state. New f count increases by 1. Because we are replacing f by 1, current sum also increases by 1. New maximum would be previous maximum plus current maximum. We put them as in the DP state. We initialize DP equal to 1, and let's probably try to debug the test cases. 1, 0, 1. Like, overall, our primary issue here would be like, or 1 second. Okay, what do we want to do is actually minimize the value here, minimum of the maximum sum. That's what we want to keep our states for, because we have a choice whether it should be true and false, right? Yeah, this works. Essentially, the idea is like this itself is the maximum sum. You don't have to take maximum or maximum, rather the minimum, because our goal is to minimize it. So this will actually solve the problem in n cube. N square DP states, and we visit all of the states at least once. Any questions, anyone? I think with this we are done. I won't be discussing problem F. I haven't read it in the context. Any questions, anyone, related to this contest or anything else? If not, then we are mostly done. And at last, do check out like this video tutorial finder with the extension I have created. Like, I'm not sure why it's not working here, but usually you will find my video links here, and you can also find other links as well. I will show you one example from the other contest. Like for this contest, I have my hints blog and the video editorial, so these links are available here. And you can even find another people's video editorial by clicking find more on YouTube. This will simply open the search box where you have other ideas with the search term. And you can also join in Telegram as well, where I usually right now I'm posting my announcements. And I'm planning to create few more useful stuff. So that's where we are. So I live somewhere in India, like I don't like the location is actually not that public, but yeah, that's fine. Please tell some resources to read. Yeah, actually you can join in my Discord server. I have a channel roadmap to read where I have put in the resources that you should try out for. First one is like you should participate in ABC contest. Then like two useful editorial is one of them is USA SEO guide. Based on your rating, it has different divisions: bronze, silver, gold, platinum. Bronze is for Div 3 or something. Platinum is harder than Div 1. So based on your current rating, you can choose one of the divisions and you can start solving problems from here. It has some topics and blogs. With each blogs, there are some text editorial, etc. on that topic, and then there are related problems for it. You can do it this way. Or you can even read CSES problem set. This is a book which is around 296 pages or something like that. Many common algorithms exist here, and you have CSES problem set as well. And the most important advice I have is you should always try to solve like solve one more problem than the number of problems that you could solve in the contest. And you can probably read what I did when I was expert, what I did when I was master, and everything. And that's where yeah. So this is where we are. Discord link here. Telegram link here, and extension link here. So thanks everyone for everyone who has been here so far. And this is where we are. Do let me know if there are any more questions. I will spend a couple of more minutes on this stream and then I will wrap it. So yeah, thanks everyone. With this, I will end my stream. Thanks a lot. Do like, share, subscribe, and yeah, that's where we are.